Chapter 11.4, we're going to talk about the comparison tests. There are two kinds. There's a basic comparison test, that's the one that usually is just called that, and the limit comparison test. Now, what we're testing for is whether an infinite sum converges, adds up to an actual real number, or diverges, doesn't add up to a real number at all, heads to infinity. Here's the test. Comparison test requires you to know something about one of two series infinite sums. We'll start with two series then. A sub n and b sub n, both bigger than 0. They have to be positive terms. So if a sub n is always bigger than b sub n, then that means we're looking for a b sub n that we know well, and a sub n one that we're trying to figure out about. If a sub n is always bigger than b sub n, and the summation of b sub n diverges, well then a sub n has to diverge too, because it's bigger than infinity. The summation of a sub n diverges too. And vice versa. If a sub n is smaller than b sub n, and we know b sub n converges, then a sub n converges too, because it's smaller than something that stays finite. So here's an example. We have a series sequence first, 7 over 3n squared plus 2n, and we want to know about the series, the sum, 7 over 3n squared plus 2n. Does it converge or not? So the idea here is that you can compare it to a sequence that's much easier, 1 over n squared. And 1 over n squared, that is a p series. It's one of the ones that we looked at earlier, and the p is the power 2 on that n, and it's a power that's larger than 1, so we know it converges. But now let's try and compare it to the bigger series, 7 over 3n squared plus 2n. So the idea is that when you add 2n on to the denominator of that and multiply it by 3, these are positive values of whole number n, 1, 2, 3, 4. So you're always making the denominator bigger, multiplying it by 3 and adding on 2n, which would be like 2, 4, 6, 8. It's definitely bigger than n squared. So that means if the denominator is bigger, the fraction is smaller. 1 over 3n squared plus 2n is less than 1 over n squared. And we know that 1 over n squared, the summation converges by the p series. It actually converges to pi squared over 6, if you want to know what value that turns out to be. That was proven by Euler. Then, now we know that the summation of 7 over 3n squared plus 2n does converge. That means that it doesn't mean that, I don't mean that it converges to 7 there. I mean it converges to 7 times some real number. So that's the 7, I pulled it out of the series because it's a common factor that multiplies every term. And then 1 over 3n squared plus 2n is the real series that I want to compare to 1 over n squared. And so I get 7 multiplied by some real number. I don't know what it is, but it does converge to something. So we say it converges. That's the most we can do. This doesn't give you a formula to tell you what it converges to. It just tells you that it does converge.